Hey guys, this is a video to bring you up to speed on some of the more important concepts from the extra low voltage switching module, specifically to the GE system. So I know it talks about the Douglas system as well as the GE system in the module, but specifically we are tested on the GE system, so we are going to be focusing on that specifically in this video. Right now I have a schematic on the board, and it's super important that you understand the function of the extra low voltage switching relay, as well as the latching mechanism and the color code. So I'm going to talk to you a little bit about that. So right now I have two circuits contained on the board. So this here would be considered your control circuit, and then this would be the power circuit. So the circuit that the control is controlling essentially. Okay, so I have 120 volts from line 1 to line 2, 120 volt system on the power side, and I'm switching then with 24 volts on the load side, AC. Okay, so it's super important that you're not crossing wires from the 120 to the 24 volt side. All switching occurs using electromagnetic induction and incorporating a latch. So we're going to look at that a little more specifically. So first of all, I'm going to talk about the function. So here I have a extra low voltage switch, standard switch. Basically it is momentary. So what happens, I come and I press the on of my switch. That brings power onto the switch leg, which is then wired to the on coil. So the difference between extra low voltage switching relays and a regular relay is that extra low voltage switching relay incorporates two coils. One coil is specifically for the function of the on, and the second coil is specifically for the function of the off. So with that being said, our coils are not continuously current carrying, however. Okay, so let's just look at that for the moment. So I come and I press the on button. Current is able to flow to the on coil, creating a magnetic field, which then attracts an armature, which then closes a set of contacts in the power. I take my finger off the button. There's no longer current flowing to that on coil, but my light stays on. And that's the unique feature of these extra low voltage switching. It's incorporated with a mechanical latch. So my light stays on due to this mechanical latch. So once my on coil was energized, created a magnetic field, it closed a set of contacts, but also attracted a latch, which will stay in place and keep the light on until the operator comes, presses the off button, which then allows current to flow to the off coil, which then takes the armature and attracts it in the opposite direction, releasing the latch and then essentially turning off the lamp. So it's super important to understand that the latch is the variable that is keeping the lights on or off. Because if it was continuously through the coils, we would have to have continuous rated duty coils. So by incorporating this latch, we are able to only have current initially for that moment when the operator is pressing the buttons. So that eliminates the need for continuous rated duty. So hopefully that clarifies what's happening within our relays and how it's controlling the light in the power circuit. Okay, so that leads me now into the color code. So specifically for first period electrical, the color code to the GE system are the questions that you are going to be asked, not just the function of the circuits. So the white wire here is what is being fed to the common of my momentary switch. So white represents the hot. Again, low voltage can have different color coding based on the manufacturer. So this is specific to the GE system. So white is bringing power to the common of my switch. The red conductor represents the wire that is going to the on function, on coil. The black is the wire conductor that is feeding the off coil. Okay. The load side of both coils are identified with a blue conductor. And you can see the load side of both coils are then connected to a diode. Okay, so the purpose of the diode is to eliminate backfeeding and essentially having our coils energized for an extended period of time. Again, these coils are not rated for continuous duty. So our diode eliminates that possibility. It only allows current to flow in one direction based on the operation of our switch. So the purpose of the diode is to protect the coils, okay? And then from the load side of our diode back to our return on our 24 volt side, our conductor is blue-white, okay? So super important that you understand the color code for the control circuit of your GE. So just to recap, a white is the hot to the switch, the red is the switch leg to the on, the black is the switch leg to the off. Load side of both coils is identified with a blue conductor, feeding the line side of a diode. The diode protects the coils from burnout, and then the load side of your diode is connected with a blue-white conductor. So that's super important. I just also want to mention that you would never have any cross wiring of voltages, right? So in your cabinets, you actually have and are required by code to have a barrier installed to keep these wires and conductors separate. So again, the switching is facilitated by the creation of electromagnetic switching through the coils, okay? So hopefully this helps. This is the more important things in regards to extra low voltage switching that you may see on your test. Any questions, please don't hesitate to connect. All right, take care, guys. Thanks.